Hello everyone, this is Dr. Kalpana and you're watching my YouTube channel Pharmacy Lessons Made Easy. The topic for today's video is the theories related to comminution or size reduction. They will include Rittinger's theory, Bond's theory and Crick's theory. So far we have discussed about pharmaceutical engineering, unit operation, the definition, different names, necessity or need, advantages, other effects and mechanism of size reduction. Not only this, we have discussed about the factors affecting size reduction in my previous videos and the classification of different types of mills based on the mechanism or mode of size reduction. We have discussed in full detail the different mills like ball mill, hammer mill, fluid energy mill. So the next topic is energy for comminution. Actually, size reduction begins with the opening of small flaws that were initially present inside the molecule or the particle which is to be reduced in size. For large particles, there are numerous flaws and it gets readily fractured. On the other hand, the small particles have comparatively fewer flaws and it is not easily fractured. It is the fact that less than 1% energy input is utilized by efficient mills to fracture the particles or to create the new surfaces. So the rest of the energy is dissipated in either elastic deformation of the unfractured particle or transport of material within the milling chamber from one place to another one. Then friction between the particles. Not only between the particles, the friction between the particles and the mill, heat, vibration, noise and inefficiency of transmission and motor. All these include energy dissipation. One thing was less than 1% energy is utilized in fracturing of particle. Rest of the energy got wasted in so many things like transportation, elastic deformation, friction, heat energy, vibration and noise. Next is so many theories have been put forward for determining this energy for comminution. To establish such relationship between the energy input and degree of size reduction, an equation has been put forward. This says dE by dt is equal to minus C upon d raised to power n, where capital E is the amount of energy which is actually required to produce a change. Its unit is kilowatt per hour. And capital D is the size of unit mass in millimeter. C is usually the constant with the unit watt per hour and small n is the constant. E is actually equal to C ln, that means natural log di by dn, where n is equal to 1. Di here is the size of the feed, initial one, right, in millimeter, and dn is the size of the product, that is the final one. It is also having unit in millimeter. Actually, the energy which is required is inversely proportional to the size raised to some power. In terms of reduction ratio, the energy required may be correlated. Now, what is this reduction ratio? Reduction ratio is actually the ratio of diameter at initial and final stage, right? So di by dn is called the reduction ratio. Different theories have been put forward for energy calculation. One is Crick's law, second Bond's law, third one is Rittinger's law. The value of n is equal to 1 in the case of Crick's law. Its value is equal to 1.5 in case of Bond's law. And its value is 2 in case of Rittinger's law. Let's discuss them one by one. Crick's theory. As per Crick's theory, the equation of energy used in deformation is equal to kk natural log di by dn. That means the energy used in deforming or fracturing the particle is proportional to the ratio of change in the size. Di by dn reflects the change in the size of the particle. Kk is actually the Crick's constant and its unit is energy per unit mass, that is kilowatt hour. Di is the initial diameter of the particle in micrometer and dn is the new diameter of the particle in micrometer. It is developed on a stress strain diagram for cube under the compression. Kick's theory assumes that material has flaws distributed throughout the internal structure, okay, and this theory is more useful for crushing of larger particles, right? So the equation is E is equal to k natural log of di by dn, okay. Moving to the next theory, that is Bond's theory, it says that the energy used in crack propagation is proportional to the new crack length produced. In the earlier statement, it says the ratio of change in size, right? Energy utilized in deformation is proportional to the ratio of change in size. It was proposed by Kick's. And Bond's theory says that energy used in crack propagation is proportional to the new crack length produced, right? So the equation is capital E, that is energy utilized, is equal to 2 kb, kb is Bond's work index, into 1 upon dn square root minus 1 upon di square root, okay. Di is the initial diameter of the particle in micrometer and dn is the new diameter of the particle, right? So energy used for deforming or fracturing a set of particle of equivalent shape is proportional to the change in particle dimensions. Next is the Bond's work index. It is actually the work required to reduce the unit weight from theoretically infinite size to 80%, passing 100 micrometer. It is actually useful for rough mill sizing and is utilized to compare the efficiency of milling operations. So this was all about Bond's theory. We have covered Kick's theory, where energy utilized in deforming or fracturing is proportional to the ratio of change in size, and the Bond's theory, which says that this energy is proportional to the new crack length produced, right? Next one is the Rittinger's theory, which says that the energy required is directly proportional to the new surface area produced, right? So the equation will become capital E is equal to Kr, that is Rittinger's constant, multiplied by Sn minus Si, that is initial specific surface area, minus new specific surface area minus initial specific surface area. Kr is Rittinger's constant, E is the amount of energy in kilowatt hour, right? So brittle substances undergoing fine milling will follow this Rittinger's theory, right? So this was the end of the theories of comminution. The next we will deal with the size separation with specific objectives of size separation. Why do we do size separation and some official standards related to the powders, right? Hope you enjoyed this video. Do click on the like button, subscribe my channel and share it on social media. Thank you. Have a nice day.